Okay, this is section 7.4 on the properties of logarithms. In this section is where we learn the product property, the quotient property, and the power property, which we're going to use in all of these examples. As always, you can pause whenever you feel like you think you need to pause and try the problems on your own before you actually see the solution. Okay, so here we go. Alright, number 1 says, write each expression as a single logarithm. Log base 3 of 9 plus log base 3 of 24. That addition, it means that I'm going to be using this property right here, the product property. Okay. Addition of two logarithms with the same base, you can actually just find the product of the two numbers. Okay, so that's what we're going to do right here. So let's see, log base 3 of 9 plus log base 3 of 24 will actually become log base 3 of 9 times 24. And 9 times 24 is 216, so it's log base 3 of 216. And that's it. Alright, now let's look at number 2. Log base 4 of 16 cubed. In this case, all we need to do is use the power property, which says that an exponent, in this case n in the property, can be written as a coefficient. Okay, it can be written in front. You can go back and forth with that. So in this one, I'm going to take that 3 and bring it down to the front to get 3 log base 4 of 16. You could actually continue simplifying this, but this is your final answer because it wants you to write it as a logarithm, so that's fine. But you can continue simplifying. Log base 4 of 16 is 2, so it's 3 times 2, which is 6. Okay, but this is fine. Okay, now let's look at number 3. Log base 2 of 7 minus log base 2 of 9. They have the same base. I see subtraction, which tells me that I'm going to be using the quotient property. Subtraction is actually turns into a division of the two numbers. So what I'm going to do here is write log base 2 of 7 over 9. Log base 2 of 7 over 9. And that's my final answer. There's nothing else to do there. Okay, let's try a few more. Number 4, log base 3 of 8 to the 5th power. All we need to do is take that exponent 5 and bring it down to the front. So we get 5 log base 3 of 8. Number 5, log base 4 of x minus log base 4 of y. Again, I see subtraction, I see the same base, so I can put them together as log base 4 of x over y. This one over this one. And number 6, log base 10 of 5 plus log base 10 of 7. Remember, when you don't write the base, that means it's a common logarithm, so the base is 10. Since I see addition here and they have the same base, all I got to do is just multiply. So it's log of 35. Okay, now expanding logarithms, the idea is the same, except now we're going backwards. Okay, you're going to try to split up the logarithm into all of its pieces. So what you're looking for is to take this and factor it. Factor it as much as you can. Break it down as much as you can so that you can split up the logarithm. Alright, so let's start with that one. Let's see, log base 3 of 27x. I can split up the 27x. Log base 3 of 27 times x. It's one of the first things that I can do. So since I see a product of 27 times x, multiplying, if I'm trying to split it up into two logarithms, is going to be addition here, just like this one. Okay, m times n turns into log of m plus log of n. So now if we go back to our problem, I got log base 3 of 27 times x. I can now split it up and write log base 3 of 27 plus log base 3 of x. You can take that even further. If you notice, 27 is the same thing as 9 times 3. Right? Let's make a factor tree for that. 27 is 9 times 3, which is 9 is 3 times 3. So 27 is really 3 times 3 times 3, right? 3 cubed. So I can go ahead and put that as a 27. Instead of writing 27, I can write log base 3 of 3 cubed plus log base 3 of x And now what I can do is I can take that 3 and bring it to the front. That power of 3, that exponent, I can take it to the front. And now my final result, well, almost final result, will be 3 log base 3 of 3 plus log base 3 of x. And then I can finally use what I know about logarithms to say log base 3 of 3 is just 1. Okay, because when you have the same base and the same argument, this is what is called the argument. The same base and the same argument, that's basically 1. So this is 3 times 1, which is 3, plus log base 3 of x. That's as simple as I can make it. Now let's look at number 8. It says log of 3 over 7. The base here is 10 because we don't write it, so it's a common log. So log of 3 over 7, I'm just going to split it up. Since I see a fraction 3 over 7, that means division. So that tells me that it's basically a subtraction of logarithms. It's basically log of 3 minus log of 7. That's it. There's nothing else I can do. I cannot split up to 3. I cannot split up to 7. That's your final answer. Let's do 9. Log base 4 of y squared z cubed. First thing I see is that I have two different bases here, y squared and z cubed. In my argument, I have two different bases. So I'm going to split that up and write it like this. Log base 4 of, in parentheses, I'm going to put the y squared so you guys can see that it's two different powers here being multiplied times each other. Y squared times z cubed. Z cubed. And now I can split that up as an addition and say log base 4 of y squared plus log base 4, again, same base, of z cubed. And now what I can do is take the 2 in the y squared, the exponent, and make it a coefficient. Take the 3 in z cubed and make it a coefficient as well. So what I write now is 2 log base 4 of y plus 3 log base 4 of z. And that's your final answer. Alright. It says log base 5 of 3 squared over x. First thing I notice is the fraction. So let's split that up into a subtraction of logarithms. So I'm going to write log base 5 of 3 squared minus log base 5 of x. Then I can take that exponent, the 2 right there, and bring it to the front as a coefficient. So I'm going to write, my final answer will be 2 log base 5 of 3 minus log base 5 of x. Alright, I think that we can move a little bit faster now. Log base 3 of 15xy. What I notice right away is that 15 is 3 times 5, so I can do this. Log base 3 of 3 times 5 times x times y. That is 15xy. And now since I see nothing but multiplication, multiplication turns into addition of logarithms, so it's basically log base 3 of 3 plus log base 3 of 5 plus log base 3 of x plus log base 3 of y. And finally, log base 3 of 3, right here in front. Remember, when you have the same base and the same argument, that's just 1. So that's just 1. So my final answer is 1 plus log base 3 of 5 plus log base 3 of x plus log base 3 of y. Okay, now that we saw all those, let's figure out this problem right here. Write 3 different logarithms. You should be able to expand each logarithm by one of the properties of the logarithms. Okay, so it's basically asking me for a logarithm on which I can use the product property, another one on which I can use the quotient property, and another one on which I can use the power property. Okay, so let's start with the product property. Basically what I need is any logarithm with any base that I want. I'm going to write base 3, where the argument is a product of two other things. So as an example, we can put 2x because it's 2 times x. That's the product property. Okay, I could expand it into log base 3 of 2 plus log base 3 of x. For the quotient property, same idea. I'm going to keep the same base, and then just write a quotient, a ratio, okay, a fraction, x over 7. There. And then for the power property, any logarithm with any base that you want, I'm going to keep it as a common logarithm, so base 10, where your argument is a power. So 7 to the x power. That's the power property. Alright, on these next few problems, we're going to use the change of base formula, okay, which allows us, remember, to change the base of any logarithm to any base that we would like. Okay, so let's start with number 14. Number 14 says log base 32 of 4. Now, it's already started for us here. It says log base 2 of 4 over log base 2 of 32. What we got to figure out is why did they choose base 2 here? Why is that the base that they chose? And then you should see that the 4 and the 32 can both be broken down to a power with base 2. So that is why they chose base 2, because both 4 and 32 are numbers that can be written as a power of base 2. So let's simplify this. Log base 2 of 4 over log base 2 of 32. I can do this. You should be able to do this in your head. If you still can't, work on it. Try to figure out what this is in your head. What is log base 2 of 4? Remember, you got to think of it in exponential form. 2 to the power of what is 4? And you should come up with 2. And for the denominator, 2 to the power of what is 32? And you should come up with 5. So your answer here is just 2 over 5. Okay? You're thinking exponential. Now number 15, log base 9 of 27. We're going to evaluate it using the change of base formula. Look at the 9 and the 27. What number do they have in common that could be the same base for both of them? 3, right? So we can turn it into a logarithm, a quotient of 2 logarithms with base 3. Now 27 first in the numerator, and then log base 3 of 9 in the denominator. And then log base 3 of 27, think, right, what is that? Think of exponential form. 3 to the what power is 27? 3. And log base 3 of 9, 3 to what power is 9? 2. So your answer is 3/2, or 1.5. Alright, now let's look at number 16. Log base 4 of 12. Now this one's different. 4 and 12 cannot be broken down into a power with the same base. 4 is 2 squared, but 12 doesn't have it cannot be turned into a power. It's 4 times 3 or 2 times 2 times 3, but it cannot be turned into a power with the same base. So in this case, what we're going to do is change the base to base 10. Why base 10? Because it's our common logarithm, and our calculators can do base 10 very, very easily. So we're going to do log of 12, common logarithm, right? We don't have to write the base, over log of 4. Again, common logarithm, we don't have to write the base. And then all we got to do is just enter log of 12 onto the calculator. We're going to get log of 12, 1.07918 approximately. And log of 4 gives me 0.6026. Do that division real quick, and your final answer is 1.792. Let's leave it like that. 1.792. So once again, let me recap the ones we just did, okay? If you can see the same base, like in number 14, log base 32 of 4, They can both be broken down into a power with base 2. So we choose base 2. We change the base to base 2, and then we can evaluate log base 2 of 4 and log base 2 of 32 really easily. Same thing for 15. I can see that 9 and 27 have a base of 3 in common. But 16, 4, and 12 do not have a common base. So what we do is just change it into the common logarithm, base 10, and then just do it in the calculator, which gives us the log of 12 and the log of 4, so we can divide. Alright, this will be the last problem in this section, this error analysis problem. It says your friend used the change of base formula to evaluate the expression log base 4 of 8. Her answer was 2/3. What error did your friend make? What is the correct answer? Okay, so let's figure out what the correct answer is, and then we'll see if we can figure out what the error was. Log base 4 of 8. I'm going to write it as a quotient, a fraction, a ratio of 2 logarithms. Okay, what base should I choose? Look at what the numbers that you have. The base is 4, the argument is 8. They can both be broken down to a power of base 2. So I'm going to choose base 2. Remember, when you're using the change of base formula, you could choose whichever base you want. Log base 2 of 8, right? The 8 on top, and then log base 2 of 4. 4 goes in the denominator. And now I can actually evaluate that. Log base 2 of 8. Think, what number, what is the power of 2 that gives me 8? 2 to the what power is 8? And you should say 3. In the denominator, 2 to the what power is 4, and you should say 2, so there's my answer. So if I compare that to the answer that my friend got, 2 over 3 compared to 3 over 2, I can see what the mistake was. The mistake is probably that he or she wrote log base 2 of 4 over log base 2 of 8. Flipping the argument and the base. The argument goes on top, the base goes in the denominator. Okay, so that is the incorrect way of doing it. It's 8 over 4, not 4 over 8.